Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syami Hadi bin Nasardin. I'm from J4EM 110-4E and my metric number is 2019400618. So for today, I will make a video about thermofluid laboratory, which is the title is energy losses in pipe and fitting. So without wasting our time, let's check this video. Bismillahirrahmanirrahim. So we will start for the objective for the energy losses in pipe and fitting experiment. So first, for the objective, to determine the losses in the pipe fitting related to flow rates, and to determine the flow, to determine the loss coefficient related to velocity head, and the third objective is to compare the losses of energy head losses in the different configuration of pipe. So next is for the safety procedure for this experiment. First of all, switch off all equipment of the experiment and make sure when we touch the switch, make sure our hand is dry and not wet. Next is wear safety boot and lab coat. So next we will go to the apparatus for the experiment. So for the first one, this is the 45-degree elbow, and the second is the contraction, third is the enlargement, fourth is the 90 elbow, and 5 is water inlet connection, this one, and 6 is the 90 degree. We can see the pipe is 90 degree short bend, and 7 is the manometer bank, 8 is the gate valve, 9 is the differential pressure gauge, 10 is the 90 elbow, and 11 lastly is the water drain connection. Now we will move to the procedure of the experiment. So first of all, place apparatus on the bench, connect inlet pipe to bench supply and outlet pipe into volumetric tank. So we will put the input pipe where we will connect the pipe into the water inlet connection, and then we will open the valve. We can see the picture above with the bench valve fully closed and the discharge valve fully open. Start the pump supply from hydraulic bench. So we will open the switch and we will start to fill the bench valve. So we can see the third procedure. Slowly open the bench valve until it fully open. As I said before, after we open the switch, we will open the bench valve until it fully open. And then when the flow in the pipe is steady and there is no trap bubble, start to close the bench valve to reduce the flow to the maximum measurable flow rate. So we will fill the manometer bank, and then after the pipe is steady, we will start to close the bench valve until it reduces the flow of the maximum measurable flow. So next for the procedure is by using bleed valve, adjust the water level in the manometer board, retain maximum reading on manometer with the maximum measurable flow rate. So this is the bleed valve. There are both on the side, one on this side and the other one in this side. So we will adjust the water level in the manometer bank, and then we will take the maximum reading on the manometer and the maximum measurable flow rate. So next is note reading on manometer and measure the flow rate with the volumetric tank. So after we adjust the water level, then we will take the reading for the manometer and measure the flow rate of the volumetric. So next is to repeat the experiment with the different flow rate. The flow rate can be adjusted by utilizing the bench flow rate valve. So you can see we will repeat the experiment with the different flow rate, and then we will adjusting the bench flow control valve. And lastly, we will repeat the step 6 where we will take the reading for the manometer and measure the flow rate by the volumetric tank. So that's it for the objective, safety procedure, apparatus and the procedure. Bismillahirrahmanirrahim. Then we will continue after we finish. Now we will continue to the result and table. So the above table is the result given in the by the lecturer. So the empty one will we fill it by value that we will calculate. So first for the flow rate we will use the formula volume over time. So the volume it will convert to the meters square. So we will get the unit is 0.000 sorry 0.000189. So for the next is 0.000181, and for the 24.97 second is 0.000160, and lastly is for the 27.29 second is 0.000117. So next we will go to the next table. So the flow rate for this table we will use from the above value. So next for the velocity in small bore pipe. So for this formula we will use the formula 4 times Q over pi d square. So the diameter for this equation is we will use the small bore pipe, which is 17 mm, and the Q is the flow rate velocity. So after calculate we will get the value. So the calculated value I have shown in the video before how to calculate the equation. So for the result and table we will fill the table only. So next for the velocity head we will use the formula v squared over 2g, and next for the differential piezometer head is for the 90 elbow we will use the formula 2 times 1 over 100 1000, and for the 45 elbow we will use 4 minus 3 over 1000, and for the sudden enlargement we will 6 minus 5 over 1000, and for the sudden contraction we will use 8 minus 7 over 1000, and for the short bend we will 10 over 9 over 1000, and the lastly 90 elbow for the second is we will use 12 times 11 over 1000. So let's fill in the table. Now we will start for the table and the graph. So after we finish the table we will plot the graph. So the graph we need for the experiment is velocity head over the differential piezometer head. So first we will take the value from the 90 elbow first. So then we will use the recommended chart, which is the scatter chart. Then after that we will get the table. So the table we will get is increase. So then we will change the chart title, which we will use differential piezometer head versus velocity head. Then after that we will use the quick layout. So this one is the velocity head. I'm sorry, this one is the 90 elbow. And for the x-axis is the velocity head. So this one will be the velocity head for the 90 elbow. So for the others, they will be the same one. So this is the table for the all the 6 of the type of the differential piezometer head. So first one 90 elbow for the first, the yellow one is the 45 elbow, the orange one is the sudden enlargement, the green one is the sudden contraction, the red one is the short bend, and the blue one is the 90 elbow for the second. So lastly is the conclusion. So first of all, the result and the key of the finding of the outcome, we successfully get all the result. So as we can see, the result for the every differential piezometer head, we will get the different of result, but for the 90 elbow and the 90 elbow 2 we will get the a bit same, and for the 45 elbow and the sudden enlargement we will get the same too, but it will be the different for 0.001. So next is the objective. So the objective of this experiment is to determine the losses in the pipe fitting related to flow rate, and to determine the loss coefficient related to velocity head, and lastly to compare the losses of energy head losses in different configuration of pipe is successfully achieved. And next is the experimental result and the theoretical result. So for this experiment, we did not have the experimental result where we need to compare with the theoretical one, and that's it for the conclusion. Assalamualaikum warahmatullahi wabarakatuh.